In this video, we'll walk through creating the Fibonacci program for the hack assembly language. The Fibonacci function, f of n, should equal f of n minus 1 plus f of n minus 2. So, for example, we need to first define f0 and f1. So f0 should equal 0, f1 should equal 1, and then we go from there. f2 equals 1, f3 equals 2, in our NAND to Tetris computer, let's lay out how we're going to use the memory. So here is our memory, and 0 through 15 are reserved for predefined values, and then 16 has our variables on from there. So let's assume that memory address 100 will be available, and we're going to use 100 to store the Fibonacci 0 number. We'll use 101 for the Fibonacci 1 number. Fibonacci 2 will go in 102, etc. And we'll continue from there. So let's start with some high-level code. So what we want to do is first set up that we'll store in RAM 100 and RAM 101 those first initial numbers. 100 should equal 0. RAM 101 should equal 1, and so this is equivalent to Fib0 and Fibonacci 1. And what we're going to do is keep track of a few variables to keep track of the current number and the previous two numbers, so we don't have to calculate them each time. So we want things like n equals the current number will be 102. And then we're going to keep track of n1 is going to be 101, and that will be n minus 1, and n2 will be 100, and that is n minus 2. So we're going to keep track of these three numbers as we keep iterating through our Fibonacci code, and let's create a limit of, say, 25, how many numbers we'll calculate. So our goal here is now to essentially have a for loop, right? So we're going to create this for loop that will go for I equals 0, I is less than our limit, I plus plus, and what this should do is we should calculate RAM of n equals RAM of n1 plus RAM of n2. And then we'll just increment all of those variables, right? So then we'll do something like n plus plus, n1 plus plus, and n2 plus plus. So that's essentially the whole program. All right, so what we need to do is start converting this into code that's going to work. All right, so I've got my text editor open, and I'm basically going to type that directly into the text editor. And I'm going to speed this up to make it faster. All right, so we basically have our handwritten pseudocode into comments in our program. I haven't commented these out yet because we'll have to go edit them. But let's start translating and see what we can figure out. So let's start up here with these things that might be easier, and then we'll deal with this for loop that'll be harder in a minute. So what I'm going to do is figure out how I can translate each one of these one at a time. So to set the value of RAM 100 to equal 0, I need to load 100 into the A register and then use the M register equals 0. So this works directly because that's one of our C commands. If I can't remember our C commands, go and look them up. Here's an overview of all the commands. This is in the slide deck from the Nanda Tetris. So all of the possible C commands are right here and the computations that can be done. So we can set constants of 0, 1, or -1. And so I basically want to do the same thing for RAM 101. All right, so that's good. And then I need 3 variables, and these variables I can just declare right where I want them. So this will be n, and then set that value m equals 102. That doesn't work, right? So the reason this doesn't work is that this isn't a C command, right? So from our C commands here, I can't set a constant value. So what I'll need to do is get that constant value into the D register first. Okay, so what I will need to do first is get the value 102 into the A register and then load that from the A register into the D register. And now what I can do is set the A register to be the variable n, and then let's load the value that's in the D register into the A register. So that's all of what's going to happen for our n, and we can basically copy and paste this for the other ones. All right, so now we've done this first part of the pseudocode. Okay. Oh, I need one more for limit. All right, so we're done with this first part of the pseudocode now, and this should match up. And this should match up with this first part of what we had here. All right, so now we need to tackle this for loop. All right, so clearly we don't have a for loop functionality. So let's go back to the paper and draw out what we need to do. So what we have is this for loop, and our for loop looks like for I equals 0, I is less than limit, I plus plus, and then we have some body. And that's our whole for loop. All right, so let's worry about just the structure of the for loop for now. And the first thing to do is translate this into a while loop. So our while loop, what happens first will be the I equals 0. And then we have a while loop with our condition, I is less than limit. And then we have our body, and I plus plus happens at the end of the body. All right, so we still don't have while loops in our assembly code, so we are going to go to one more version, which will be a goto version. All right, so what has to happen in our goto version is we're first going to essentially use an if statement, right? So we're going to say I equals 0, and then we'll have an if statement if I is greater than or equal to 25. So what I'm doing here is I'm reversing, or the limit actually. I'm going to reverse our condition, right? So this is the equivalent of not the original condition. And so if this happens, then we'll go to end. Okay, and then otherwise we have our body, and then we have our I plus plus, and then what I need to do is loop back around, right? So what I need here is a label. We'll call our label loop, and we'll say essentially no matter what at this point we'll go to loop. And at the end, we need another label that's basically says the end. All right, so we're taking our for loop, translating it into a while version, and then translating that into a goto version. All right, so why don't we change our pseudocode over here to be closer to what we have in our drawing. So here's our body, right? I'm going to leave that, and so then I'm going to add I++, and then go to loop. We need to define our loop up here. And we need to define an end down here. All right. So this is essentially what's our go-to version of the loop. We still don't quite have if else, and then we'll need to translate all of these lines of code into assembly. All right, so let's get started. All right, so in order to translate the if statement, what I need to do is convert this first into something that compares against 0. So I'm going to make a copy of my comment and basically subtract the limit from both sides. So this will be if I minus the limit is greater than or equal to 0 is what we're looking for. So what we need to do is we need to calculate I minus limit. So let's calculate I minus limit. So we're going to load I into the A register and then read that memory from RAM into the D register. And what we need to do now is also do the same thing with limit. So we'll load the limit into the A register. My autocomplete's not behaving. And then we'll load that into the A register. So we'll say the limit goes into the A register. So what we have now is the D register is going to hold I, the A register is holding limit, and let's subtract them and put the result into the D register. So now we're going to say essentially the A register, or the D register equals D minus A, right? So D minus A, so D is essentially I minus limit. All right, and what we're now comparing against is I minus the limit greater than or equal to 0? And if it is greater than or equal to 0, then we want to jump to the end. So what we're going to do is we'll load the label end into the A register, and what we'll check now is the current value of D greater than or equal to 0? If so, we're going to jump. So jump if greater than is our command to jump to the label of the A register only if this is greater than or equal to 0. All right, so this translates this code right here. All right, so I'm going to leave these comments right there. And basically jump if D is greater than or equal to 0, and we just said what D was right there. All right, so we have N down there. Let's see, we need a go to loop. Might as well go translate that in there. Right, so go to loop is going to translate into at loop, and then any C command followed by jump. All right, so this is essentially go to loop. All right, so loop is done. We haven't done this I equals 0, so let's translate this line. So I equals 0 is going to be at I, and then just say M equals 0. All right, so that should translate that. All right, so we have a few things here, right? So we have all these plus pluses, and we have this kind of ugly looking thing to figure out. All right, so the plus pluses should be relatively easy, right? So we should be able to do for any of these plus pluses is translate them into, and so actually let's leave them. Let's translate them into at I, and then M equals M plus 1. So that should be I plus plus. Same thing for all these other ones. This one here should be at N2, and then m equals m plus 1. And the spacing doesn't really matter. You should try to keep a consistent style. I don't know if it really matters. All right, so now we have essentially all of these pluses, and the only thing left, I think, to translate is going to be this. All right, so this is going to be a little bit tricky, right? So the way to think about what we want to do here is we need to read this value first, and then we want to read this value and add them together, and then store the result here. All right, so let's worry about this one first. We're going to read RAM of N1 here. So let's first get the value of N1 out of memory, right? So we're going to have to read N1, and we're going to turn this into a comment. So N1 and A equals M. So this should essentially read the value from N1 and then use that value to load that value from memory. All right, so here essentially is use N1 as a pointer. And so the first time around, for example, N1 will be the value 103, right? And so what this would do is this one will read the value 103 and put that into A. And now what we'll do here is we'll use 103 as a memory address and read the value that's in 103. Or actually 103, N1 at first will be 101 or 102, whatever the initial value was up here. Okay, so that's basically going to read the value from memory, and we're going to do the same thing with N2, except we're going to store it into D. Okay, so let's basically copy this code here, use N2 as a pointer. Oh, sorry, I mean we're going to store it into A, and we're going to store the result into A, right? So at this point, we have A is holding RAM of N2, right? D holds RAM of N1. Okay, and so what we want to do is add them together. So let's add those together. Say D equals D plus A. Right, so now D equals essentially this part here. All right, and now what we need to do is store the result into RAM of N. All right, so let's essentially figure out how we're going to do that. So now we need to store the result into RAM of N. So what we need to do is load N into the A register. Then let's use that, the memory into the A register. And so this gets essentially our pointer. Remember, we're using this as a pointer again. And now what we're going to use is essentially use that pointer to store the value from the D register. All right, so this essentially stores RAM sub N equals D. So we store the value from D into memory using N as a pointer. Okay, and so then we increment all of our things. We go around in our loop, and it's good practice at the end to have essentially an infinite loop. So we'll say at end and then 0 jump. And this should just jump repeatedly in an infinite loop down here. Okay, so I think we're good. Let's go try it. So I'm going to save my work, and I'm going to load this up in the CPU emulator and see what happens. All right, so I've loaded my program up into the emulator. I could hit this button to just run it. I could run this button to step through it. So let's step through it and see what's happening. Right. So here was essentially the line that we're working on in my code. We can see it over here in our ROM, and so we have at 100 m equals 0. So that should be fib 0 equals 0, and then we have at 101 and m equals 0. And so that should be fib 1 equals 1. Oh, so there's a bug already. All right, so actually we have a bug. This should have been load m equals 1. Okay, so this is one reason to step through your code, but actually I'm curious what's going to happen if I keep running this. So what's going to happen is we're going to add 0 and 0 together, and so the third Fibonacci number, or Fib2, is going to end up be 0 plus 0 equals 0. So if I keep running this, it's not going to give us any good answers. All right. Let me pause here for a second. We can actually see the other things that are going on here. So here's our variables, right? Our variables started at 16, and we had n minus 1 and n minus 2, so that's fine. This was our limit variable. So down here we had our limit was 25, and then we had our counter I was counting up from 0. So here was limit, and here was our counter. So we've done 2 iterations so far, and if I scroll down, what I should see in 100 is we should have fib0 is 0, fib1 is 1, fib2 is some value, and we don't see that, right? And so actually we already noticed the problem earlier, but this is one way to fix it. So now that I've fixed it, let me make sure I save my work, and I'll go reload it. Save the work, load program, and I'm going to reset everything. So I'm going to reset the script, and I'm going to go clear the RAM, so all of those things disappear. All right, so now let's go start again, right? So at 100, m equals 0, so that's fib0 equals 0. We have at 101, m equals 1, so now we have fib1 equals 1, which is what we want. All right, awesome. Now we're going to do a few other things. We're going to set up our variables for, here was 16, so 16 is going to set the value 102, so this was our variable n. Now we'll load our variable n minus 1 and our variable n minus 2 into these 3 memory addresses. We'll step a few more. We should load our variable limit was 25. We should load the value 0 into our value for I. And now what we're going to be doing is essentially we're already calculating at this point the conditions of our loop, right? So here's the conditions of our loop. We had our, we see our d equals d minus a. So here's d equals d minus a. And what we're calculating is if we're done with the loop, and what we're not. So we're not done. So we basically are not going to jump to instruction 49 at this point, because the value coming out of the ALU is not 0 or greater than 0, right? So we see the value coming out of the ALU here is negative 25, which was our I minus limit. So 0 minus 25 is 25, so we're not jumping yet. So we're going to stay inside of our loop, and now we're going to execute our values in the loop. We're basically getting our fib n minus 1 and our fib n minus 2. And what we're going to do then is essentially load those in here and add them together and then store them in 102. All right, so here is now our Fibonacci, our second Fibonacci number. So fib2 is 2. All right, and what should happen now is we increment a bunch of variables, and then we're going to get down here and jump back to instruction 22, which was our loop. And so if I just set this to run, and actually I'm going to speed it up so it's sped up pretty good. We'll let it run for a little bit. The other thing you could do is turn off the program flow to see how fast it's running. And I'll stop it after a minute, or actually let's keep it going. Let me speed this up to the end. All right, so I just paused it here. So we're see our 19 was our limit, our 20 was our I value, and our I value is 24. And so let's actually see where we're going to stop here. And we basically just finished, right? So we're at the end here, and what we're doing is just jumping back and forth in this infinite loop between the end, because we had jumped out of this if statement, basically decide to go to end, right? So when we reached our I value, which was greater than, so I minus the limit was greater than or equal to 0. So when we got to 25, this became greater than or equal to 0. And we jumped out to the end. All right, so let's scroll down and see what we see in the memory. All right, so far looks good here. All right, so here's our Fibonacci sequence. Let's remember what we're expecting to see. So we were expecting to see 0, 1, 1, 2, 3, 5, 8, 13, 21, 34. And here we go. That's what we're expecting. Wait, no, it's not. We have 1, 2, 4, 8, 16, 32. All right, so we have powers of 2. It's doubling each time. All right, so we're not adding together the previous two numbers. What we're doing is we're doubling the number each time. So we're adding the same number to itself. So we go back and look at our code. We're trying to debug. All right, actually, so here's where we're getting these two numbers from. All right, and actually I used the wrong variable again. All right, so we're going to fix this variable, n1 and n2, and let me save our work, and we'll go back and reset and rerun the whole thing. Load program, fib demo, reset, run. Just wait a second. Let's see how long it goes. All right, hit stop. All right, actually I should have reset all of this. Clear the memory, reset, stop. All right, so we're done, and we can know we're done because we're stuck in this infinite loop. And if I scroll down, actually we see our limit, and here was I and our limit. So we had finished with how many we wanted to do. And so now we go here, and we have 0, 1, 1, 2, 3, 5, 8, 13, 21, 34. Yay, Fibonacci sequence. All right, so this is exactly what we wanted. And if we keep scrolling, it looks good. And then, oh, all of a sudden, negative numbers. All right, so question for you: why all of a sudden did we lose our Fibonacci sequence? So that's the question for class.